Hello, I welcome you to this e-learning module organized by the European Coastal Flood Awareness System, the ECFAS project. My name is Juan Montes. I'm a member of the Department of Earth Science at the University of Cádiz in Spain, and in this module, I'm going to introduce you to the concept of threshold of total water level. The objectives of this module are understand the importance of this task for the project, understand what is a threshold, what is the definition of threshold for the project and how they have been calculated, and how thresholds have been related using different databases. As a context, the main objective of ECFAS is to develop products and tools for the evolution of the Copernicus emerging service in the coastal area. ECFAS will provide and demonstrate tools, methods, and protocols that will focus on the implementation of a coastal flood awareness system using the European Sentinel series Earth observation data, complemented by the integration of previous EO missions like Landsat and contributed missions, in conjunction with oceanographic modeling, high-resolution land use land cover mapping of the coastal area, location and characteristic of exposed asset, including the population, and numerical modeling of coastal floods. In this sense, the thresholds are the link between the hindcast and forecast portion of total water level and the coastal flood impact assessment on assessed and population. As input, the calculation of the threshold benefits from several tasks performed in the project, such as the forecast of total water level, the production of a calibrated hindcast of total water level, and the validation of the models. For more information, please visit the project website where you can find different technical reports and scientific publications. As mentioned, the thresholds are the link between the total water level forecast and the warning component of the project, and from them the system is activated, as you can see here in the general framework of the warning component. If the total water level exceeds the threshold, the system is activated. The most appropriate scenario for flood and impact model are localized, and all the information related to the event, including the warning layer, is generated. For more information, please see the other related ECFAS e-learning modules, such as the module Forecast and Hindcast of Marine Hazard for Coastal Flood Management, the module Flood Modeling Component and Products, and the module The ECFAS Impact Approach. As can be seen here in the slide, the total water level is the result of the sum of different components, and here you can see several of them. Although the sea level rise has not been taken into account in this case. When the total water level, due to storms, exceed normal levels, can generate erosion and flooding processes in coastal areas. The definition of a storm is a disturbance of the atmosphere marked by winds and usually by rain, snow, hail, sleet, or thunder and lightning. But defining which are the storm conditions for coastal area is not a simple task. So to define which are the storm conditions is used a statistical approach to identify it. And those are the threshold. The total water level from when storm conditions are considered that allow identification of events that can generate erosion or flooding processes. In ECFAS, due to the needs of the project, two thresholds were defined. The triggering threshold is the local reference to trigger the flood forecasting system in case of forecasted total water level exceedance. The duration threshold is used to determine the storm duration and plays an important role in the appropriate selection of flood scenarios. In this case, the 1-year return period was selected as the triggering threshold and the 99th percentile as the duration threshold. To obtain the return period, an stream value analysis was performed. The stream value analysis was carried out based on the methodology of Mentaski 2016, using a minimum time difference between peaks of 72 hours, using an average number of events per year of 5, and applying a generalized Pareto distribution. In addition, a duration analysis was carried out to identify the appropriate method to evaluate the storm duration. Select the appropriate range of duration as an input for ECFAS catalog and to identify a storm considering critical condition threshold for total water level. Based on this analysis, the 99th percentile was determined to be the best choice for the duration threshold and European scale. In addition, a range of duration was obtained for the ECFAS catalog. To select the previously mentioned parameter for the stream value analysis, Different parametrization were tested to assess the sensitivity of the stream value analysis to the threshold parameter and time windows for stone declustering. Two different percentiles were used as total water level threshold to select the independence event, percentile 97 and percentile 98. For each percentile, 3 time windows for stone declustering were used, 24, 48, and 72 hours. To guarantee the security of the system, since the threshold were used for a warning system, the parametrization that gave the lowest value was chosen. And as a result of the application of the stream value analysis, the return period for 1, 2, 5, 10, 20, and 50 years were obtained. In addition to establishing the trigger threshold, this analysis was used to establish the different scenarios in the ECFAS catalog. Complementarily, in order to compare and validate the result of the stream value analysis, information of real cases was used to compare with the total water level of hindcast during the event and with the different return level and threshold extracted from the stream value analysis and the duration analysis. These real cases were defined in a database of stream event previously developed in the project. The slide showed the case of the stone Santa Agata in Lito della Nazione. In this case, the reported value, although slightly lower, is similar to the maximum average value of the ECFAS combined hindcast for this event. The stone was classified as severe because of the impact as well as the magnitude of the event. And this is also observed in the stream value analysis, where the total water level almost reached the value of 20-year return period. In the case of the stone Cynthia, in La Faute-sur-Mer, the value for return level obtained from the stream value analysis are slightly lower to those reported. The difference is due to the fact that it was measured in an exposed area for the waves, which explains the difference. Therefore, the EVA appeared to be quite accurate in this test case. Both reported from the database and stream value analysis return levels refer to a high magnitude event driven by an expected stone surge. Finally, due to the temporal coverage of the database available for the project, both hindcast and forecast were used in the ECFAS. The first 10 years extension and the second one 2 years extension. Since the threshold were originally calculated with the hindcast and the system worked with the forecast, it was necessary to find a function that links both datasets and allowed to translate the threshold from one dataset to the other. To do this, the stream value analysis was applied to the 10 years hindcast. Total water levels time series were created for the overlapping period of both datasets. The percentile was extracted to which the value of return level for 1 year return period correspond in the hindcast overlapping time series, and the value to which this percentile correspond in the forecast overlapping time series was extracted. After translating the threshold, if the total water level is higher than the forecast triggering threshold, the system is activated. This methodology allows to have a consistent activation of the system. To summarize, this e-learning module has shown the importance of defining reference for the project, has explained what the thresholds are and how they were calculated and validated in the project, and has shown the importance of have consistent activation of the system. If you have any question, please do not hesitate to contact us at the project email address, and thank you very much for your attention.